Hello viewers, in today's class we are going to discuss one important problem from three-dimensional geometry, right? And this problem is related to finding out the equation of a plane when some conditions are given, right? So we have already discussed these type of problems in our earlier lectures. So here once again we are going to take up one more important problem, right? So here let us first read out this question. The question goes like this: find the equation of the plane passing through the point 1 comma 1 comma minus 1 and perpendicular to the planes whose equations are given here, right? So here we have to find the equation of a plane which passes through this point, right? And that plane is perpendicular to these two planes, right? So now let us start, and let us first take the uh, point 1 comma 1 comma minus 1, right? So let us take this plane as our required plane whose equation is to be determined, right? So this plane passes through this point 1 comma minus 1, right? So we know that if a plane passes through a given point, say x1 y1 z1, then the equation of such a plane is given by a times x minus x1 plus b times y minus y1 plus c times z minus z1 is equal to 0, right? So this is the equation of a plane which passes through a given point x1 y1 z1, and here our point is 1 comma 1 comma minus 1, right? And moreover, see here we have the coefficients a, b and c. So a, b, c are the direction ratios of the normal to this plane, right? So let us take this as the normal vector to this plane, and this normal vector has the direction ratios a, b and c, right? So let us now first substitute the values of x1 y1 z1 in this equation. So we'll get a times x minus 1 because x1 is 1, then b times y minus 1, y1 is 1 and z1 is minus 1. So here we'll get c times z plus 1, right? So let us call this equation as equation number 1, right? So our required plane has this equation, and if we observe this equation, we see that we have to find the values of a, b and c. That is, we have to find the direction ratios of this normal vector, right? So once we get the direction ratios of this normal vector, we can easily find out the equation of our plane, right? So we can substitute the values of a, b, c, and it is simple to get the equation of our plane, right? Okay, so now we have used this condition. Now the remaining conditions are that this plane 1 is perpendicular to this plane and this plane, right? So let us call this plane as plane number 2, and let us call this plane as plane number 3, right? So this plane 1 is perpendicular to 2 and 1 is also perpendicular to our plane number 3, right? So now let us see what would be the condition when two planes are perpendicular. So now let us consider here two planes, right? So let us take the rough diagrams here. Suppose this is one plane, and let us take another plane like this, right? Suppose we have this plane, and suppose these two planes are perpendicular to each other, right? So let us first draw the normal vector to this plane, right? This is, suppose this is the plane number 1, and let us take this plane as plane number 2. So this is the normal vector to this plane, right? And let us draw the normal vector to this plane, right? And the normal vector, it goes like this. Suppose, so these two vectors, that is the normal vectors to these two planes, are also perpendicular, right? So what we conclude from here, that if two planes are perpendicular, then their normals are also perpendicular, right? So here this plane 1 is perpendicular to this plane, so their normals are perpendicular to each other. Suppose we denote the normal vector of this plane as n1, so n1 is perpendicular to the normal vector to this plane n2, right? And similarly, our this plane 1 is also perpendicular to this plane, right? So let us denote the normal vector of this plane by n3. So we have n1 perpendicular to n3, right? So this is the core concept while solving these type of problems, right? So when two planes are perpendicular, their normals are also perpendicular, right? So these two planes are perpendicular, so their normals are also perpendicular, and this angle is pi by 2, right? So now see what we have got here. We have got the perpendicularity of two vectors here, right? So n1 vector is perpendicular to n2 and n1 vector is perpendicular to n3. Now let us write the direction ratios of vector n1, right? So n1 vector is normal vector to this plane, and this plane has the direction ratios of the normal vector are a, b and c, right? So the direction ratios of n1 vector are a, b and c, right? And the direction ratios of n2 vector, right? So n2 vector is the normal vector to this plane, so the coefficients of x, y and z are the direction ratios of the normal vector to this plane, right? And these are 1, 2 and 3, right? So from here we got this, right? Okay, now again this plane is perpendicular to this one, so the normal vector is also perpendicular to the normal vector to this plane, and the direction ratios of n1 vector are again a, b, c, and this is perpendicular to the normal vector n3. So the direction ratios of n3 vector are the coefficients of x, y and z. So see, here we have 2, minus 3 and 4. So here we got 2, minus 3 and 4, right? So now let us apply the condition of perpendicularity of two vectors, right? Suppose we have two vectors whose direction ratios are a1, b1, c1 and a2, b2, c2, right? And if the two vectors are perpendicular, then obviously their dot product is 0, right? So a dot b is equal to 0. So the condition for a dot b is equal to 0 is that we multiply a1 a2, then we multiply b1 b2, and then we multiply c1 c2, and then we add them, right? And this is equal to 0, right? So this is the condition for two vectors to be perpendicular. Their dot product must vanish when the two vectors are perpendicular. So here in this case what we will get, see, we have a times 1, then we have b times 2, then we have c times 3 is equal to 0, and in this case we have a times 2, then b times minus 3, then we have c times 4 is equal to 0. Now let us rewrite these equations as a plus 2b plus 3c is equal to 0, and here we have 2a minus 3b plus 4c is equal to 0, right? So now we have two equations to solve, but here we have three variables, right? And in order to solve these two equations, so we can either use the method of cross multiplication, or by the method of elimination, right? So here we will prefer to use the method of elimination, right? So in method of elimination, what we do, we try to eliminate one of the variables, right? So here we see that if we multiply this equation by 3 and this equation by 2, then we can easily eliminate b, right? So let us rewrite the equation. So here we'll have 3a, then we have 6b, then we have 9c is equal to 0, and here we have 4a minus 6b plus 8c is equal to 0, right? Now let us add these two equations. So as 6b and minus 6b get cancelled, here we'll get 7a, and here we'll get 17, c is equal to 0, right? So now we have two variables. So we can now write this equation as 7a is equal to minus 17c, right? So once we get an equation in two variables, what we do, we introduce a parameter lambda here, right? So we'll introduce a parameter lambda, where lambda is some scalar. So now we can write the values of a and c in terms of lambda, right? So 7a is equal to lambda, so a is lambda over 7, and from here minus 17c is equal to lambda, so c is minus lambda over 17, right? So now we have got the values of a and c in terms of lambda. Let us substitute these two values in one of these equations to get the value of b, right? So we'll substitute a and c in this equation. So what we will get, c will get lambda over 7 plus 2b, then we'll have minus 3 lambda over 17 is equal to 0. So this is 2b, that is 3 lambda over 17 minus lambda over 7, right? So now this is, if we take the LCM here, so 17 times 7 is 119, and then we have here 21 lambda minus 17 lambda, and here we have 4 lambda over 119, right? So 2b is equal to 4 lambda over 119, and this 2 and this 2 get cancelled here, so we have b is equal to 2 lambda over 119, right? So viewers, here we have got the values of a, b, c in terms of our scalar or the parameter lambda, right? Now the final step is to substitute the values of a, b and c in this equation number 1 to get the desired equation of our plane, right? So now let us substitute the values of a, b, c over here. So what we will get, we have lambda by 7, and here we have x minus 1, then we have b, that is 2 lambda over 119, and y minus 1, and then we have c, that is minus lambda over 17, and here we have z plus 1 is equal to 0, right? Okay. So now what we will do here, see this parameter lambda occurs in all the three terms, right? So we can, if we divide both sides by this lambda, because lambda is a non-zero real number, right? So we can easily get rid of lambda here. So we'll get 1 over 7 x minus 1, then we have 2 over 119, y minus 1, then we have minus 1 over 17, and z plus 1 is equal to 0, right? Okay, so once we have eliminated this lambda, now we have in the denominator 7, 119 and 17, right? So the LCM of 7, 119 and 17 is 119, and we can now multiply this entire equation by 119, right? So now what we will get here, C will get 119 over 7 x minus 1, and here 119 get cancelled, so we are left with 2 times y minus 1, and here we have minus 119 over 17, and this is z plus 1 is equal to 0, right? So this is 7 17s are 119, so here we have 17 x minus 1, this is 2 times y minus 1, this is 17 7s are 119, so here we have minus 7, and z plus 1 is equal to 0. So this is 17x minus 17 plus 2y minus 2, and minus 7z minus 7 is equal to 0, right? So now if we rearrange this equation, we'll get 17x, then we have plus 2y, then we have minus 7z, and minus 17 minus 2 and minus 7 is minus 26 is equal to 0, right? So viewers, the equation of this plane is given by this equation, right? So this is 17x plus 2y minus 7z minus 26 is equal to 0, and moreover here the coefficients of x, y and z are 17, 2 and minus 7, right? So these are the direction ratios of this normal vector n, right? Or we can call it as n1. So the direction ratios of the normal to this plane are given by 17, 2, 2 and minus 7, right? And we can also express this equation in vector form. So the vector form of this equation is r dot, we'll write 17i cap plus 2j cap minus 7k cap is equal to 26, right? So this is the vector form of this equation, which is similar to vector r dot vector n is equal to a, right? So viewers, this is how we can solve these type of problems in three-dimensional geometry.